Welcome to this advanced video diving into the automated test execution via the Trastronic tool test guide. It explains which possibilities you have to specify the exact scope of your test execution. So it provides an in-depth insight into Playbook steps, their different types and their configuration options. To understand this video, you should have basic knowledge about the automated test execution with test guide. For this, just have a look into our two introduction videos. In another advanced video about test source and dependencies, you can learn how to build your execution environment such that all required files are available on the test resource at the beginning of the execution. This video faces the challenge how to define a structure for the test execution. That is, what exactly should be executed, at which point and with which settings. For this, you need to configure Playbook steps, which refer to the available files on the test resource. The steps are either for starting and stopping ECU-TEST on the test resource, or they correspond to calls of specific ECU-TEST files, for example, ECU-TEST packages, ECU-TEST projects, or ECU-TEST configuration changes, or they correspond to any process calls on the operating system of the test resource. The steps of a playbook are structured in three blocks: setup, execution, and teardown. Setup and teardown steps are intended as preparation and cleanup for the test resources. They are executed in exactly the same order as specified. The test cases in the execution block represent the test scope of the playbook. They do not have a guaranteed order and therefore should not depend on one another. Therefore, in certain scenarios, it is possible to automatically distribute them over multiple test resources which fulfill the requirements of the playbook. There are also differences in the way errors are handled. If a setup step fails, all following setup steps and test cases will be skipped, and the teardown steps will be executed next. If on the other hand a test case or teardown step fails, the execution continues with the next test case or teardown step. I will now have a closer look at the specific playbook step types and their configuration options. Before ECU-TEST can execute anything, it must be started first. For this purpose, you need to add an ECU-TEST start step. Sometimes, at the moment when you want to execute your ECU-TEST start step, there is no valid ECU-TEST license available in your test environment. In this case, you can specify to wait for a valid license forever or for a fixed number of minutes before the execution will be aborted. At the end of your execution, you should stop your ECU-TEST with the ECU-TEST stop step. ECU-TEST start and stop steps can only be performed in the setup or teardown block of a playbook. Now imagine that you have multiple playbooks using the same ECU-TEST workspace as a test source, and it always takes a long time to start ECU-TEST with this workspace. Then it could be helpful to reuse the ECU-TEST instance once started on the test resource also for the following playbook executions. This would save the time which is needed to start ECU-TEST several times. For this purpose, you can omit the ECU-TEST stop step. Instead, just specify in the ECU-TEST start step that an already running ECU-TEST instance should be reused if it exists. Anyway, if no running ECU-TEST instance exists, always a new ECU-TEST instance will be started. You can also configure to keep the already loaded test configuration file and test bench configuration file if you want to reuse ECU-TEST. Note that the reuse option requires that all playbook executions running on the test resource use the same ECU-TEST workspace as their test sources. ECU-TEST configuration changes can be executed via the ECU-TEST configuration change step. When adding this step, you have to configure the file paths to the test configuration file and the test bench configuration file you want to load. These file paths have to be given relatively to the checked out workspace source. If you leave one of the file paths empty, the corresponding configuration file will be unloaded. You can additionally specify global constants, which can be used in all following ECU-TEST steps as long as the specified configuration files are loaded. ECU-TEST configuration change steps can only be performed as setup or teardown steps of a playbook, and an ECU-TEST start step has to be executed beforehand. The actual test cases of a test execution are usually defined within ECU-TEST packages or projects. To execute an ECU-TEST package or project, you can use ECU-TEST package or ECU-TEST project steps. For an ECU-TEST project step, you first need to specify the file path of the ECU-TEST project relatively to the workspace source. You can additionally configure global constants, which can be used within the project execution. Imagine you have specific project steps just for the preparation of your actual test cases, but you are not interested in the test results of these steps. For this use case, you can simply deselect the automatic report upload via the test guide resource adapter. There may be situations where, while the execution of a project step, ECU-TEST hangs up and the execution never gets finished. This is a really bad situation because your test resource may be blocked for a long time until you realize the problem. For this, you can specify a timeout at the ECU-TEST project step. When the timeout is exceeded, this step will be aborted and the execution will continue with the next playbook step. ECU-TEST package steps have the same configuration options as ECU-TEST project steps, but you can additionally specify package parameters. These package parameters can be used within the package execution in ECU-TEST. ECU-TEST package and project steps require an ECU-TEST start step to be executed beforehand. They can be used in all playbook blocks: setup, execution, and teardown. Sometimes you want to do things within your playbook execution which can't be realized with ECU-TEST or which do not need a running ECU-TEST instance. For this purpose, playbook command steps can be used, in which you define process calls on the operating system of the test resource, similar to calls on the command line. To define a command step, you first need to specify a command and its required arguments. You can additionally configure environment variables, which can be used within the command execution. Command steps can also be used to control the execution flow to some extent. That is, they enable you to conditionally skip the execution block and optionally the teardown block. To activate this behavior, use the semantic interpretation option. Exit code 0 means the execution will be continued with the next step. The exit codes 1 to 4 provide different options to skip the execution and teardown block and whether to treat the execution as successfully finished if some of those parts were skipped. For command steps, just like for package and project steps, a timeout can be defined after which the command execution is cancelled. Playbook command steps do not need a started ECU test and can be used in all Playbook blocks: setup, execution and teardown. The results and logs of the executed Playbook steps can be viewed in the details page of the execution task, which was generated from the Playbook. You can see here if a Playbook step was executed successfully or with an error, finished with a specific ECU-TEST verdict, or if it was aborted, timed out or skipped. To see the logs in this view, a log archive has to be configured beforehand via the execution settings page. The logs will be uploaded to the active storage of the specified depository. Today, you learned something about Playbook steps, their different types and their configuration options. You now know which possibilities you have to specify the exact scope of your test execution and why to differentiate between setup steps, test cases and teardown steps. You may also have a look into our other advanced videos about the automated test execution with test guide. Thank you for listening and I hope you enjoyed the video.